Hello everybody, it's Miss Talhami and welcome to your last recording for distance learning for Advanced College Prep Algebra. So our goal today is to be able to graph and solve quadratic inequalities. So if you remember, inequalities meant that I have a greater than, a less than, greater than or equal to, or less than or equal to symbol. Now it's very similar to when we used to graph linear inequalities, where if there's no line, then it's dotted. If it's a solid line, then it's a solid line. So if it's an or equal to, it'll be a solid line. If it's just a less than or a greater than, it's going to be a dotted line. When it's a greater than, when y is greater than, you're going to shade above. When y is less than, you're going to shade below. So you really have to remember those things. So maybe we'll jot them on the top as little reminders. So maybe a little reminder here. If it's less than or equal to or greater than or equal to, because it has the equal to sign here, you're going to have a solid line. And then if it's just here, you're going to get a dashed or a dotted line. So that's one reminder. So that was one thing we just mentioned. And then the other thing you had to remember that I just mentioned is if y is less than or equal to, you shade below. And if y is greater than or equal to, you shade above. So very important you know the difference there. Okay, so let's use that information to help us with the first one here. Now, pretend this says y equals. Now, you know that since there's a negative up front, it's going to have to be a frowny face. It should be open downwards. And that's the opposite sign and the same sign for my vertex. So what you could do is you could just put this in the calculator in the y equals and get the coordinates. Either one is acceptable. But it's good to know how to graph. Okay. And now since this is a greater than, I'm going to do, it's a dashed line because there is no equal to sign. And since y is greater than, I have to shade all above this. So now y is greater than negative x plus 1 squared plus 4. So when I shade this, everything above, all of these coordinates that I'm shading in are solutions. So I could pick any one of these coordinates in the shaded area, any one of these. So here is a solution, here's a solution, here's a solution. But this is not a solution because it's a dotted line. Remember the difference? We did that when we did linear. I hope you remember it. Let's try this next graph. Okay, so we have x minus 3 squared. So that means my turning point is going to be at positive 3, 0. And it couldn't hurt to always check the table, but 3, 0 should be your turning point in this example. So you can always check the graph here. Now here's 3, 0, and then the rest should look just like this. Now, because it's just a less than symbol, it's still a dotted line. It is not solid. So a dashed line, whichever one. I'm always labeling when I'm done. It always reminds me what I have to do. So y is less than x minus 3 squared. So now, since it's less than, that means to shade below. So this is all the space below the curve. Let's try the next one. So here I have a negative, so it's going to be open downward. Plus 4, inside means the opposite, so this is going to go to the left 4 and down 2. So let's try this out. To the left 4 and down 2. And it's going to open downwards. So that means it should go this way. So I'd always like to confirm in the calculator just to check my work. -2. Yep. So here you have it. Now it's because it's greater than or equal to, we're going to have a solid line because of the or equal to. I'm going to label it. And since it's greater than, I have to shade above the curve. So everything, this is all the space above the curve. And then, with this last one, 2x squared minus 5, if you notice, that means the turning point is at 0, -5. So 0, -5. And then the 2 up front positive means it's going to open upwards and everything is going to be double. So it's going to be narrow. So here I should be at +3. And because it's less than or equal to, this should be a solid line. Make sure you label it. And then, since it's less than or equal to, you have to shade below. So everything in the shaded region is a solution. If it's a dashed line or a dotted line, any point on the line is not a solution. But here, since it's a solid line, any point on the line, so this right here is a solution. So that's how you graph quadratic inequalities. So if you want to practice first before we get to numbers 5 and 6, there's 2 pages of practice. So 1 through 12 here of the practice problems that you can sketch the graph of each function. You can use your calculator to help you get the coordinates, or if you remember how to sketch it, you could do it yourself. But the second thing I'd like to review is how to solve quadratic inequalities. So here, you can graph them if you'd like, but it has here x squared minus 5x minus 6 is greater than or equal to 0. Now, if I wanted to graph this, I'll show you in just a second. We really need to focus on what values of x would make this greater than 0. So my first step is I'm always going to see if I can factor this, because I want to do, it says here algebraically. So if I want to factor it, so I have to think, are there 2 numbers that multiply to give me 6 and add to give me a -5? So there are. If they multiply to a negative, the signs are different. And then the greater one is negative. So a -6 and a +1 are the correct factors here. X minus 6 and x plus 1. So that means if I were to solve here, I get that x equals 6 and x equals -1. So really on the graph, okay, so it looks something like this. And because it's positive, I'm just going to sketch this. So it should look something like this. So there's the graph. So now it's asking what values of x will make this greater than 0. So really I have to focus on my values of x here. So I need to focus on the x-axis. So if I focus on the x-axis, I can make myself a number line. So this is how we show, if you remember, solutions to inequalities. We use a number line. So I'm going to go from -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Now, because it's a greater than and not a greater than or equal to, if you remember, that means I have to have open circles at -1 and at +6. Now, the question is, which set of numbers? Now, if you remember, there's and, where it would be between, or where it would be the outsides. So here, my safe number I can always check is 0. Now, if I plug in 0 into this equation, 0 squared minus 5 times 0 minus 6, let's see what I get. 0 squared is 0, -5 times 0 is 0, so I'm left with a -6. Is -6 greater than 0? This is false. So since this is false, that means 0 is not an answer, which means it is not an and, but it is an or, so the outside. So what that means on the graph is that all these x values here are the correct answer, which makes sense because if I replace this with a y, this is y is, I know it looks like the greater than symbol, but if I read it backwards, y is actually less than the x squared minus 5x, so everything below. So that would make sense that it was an or statement to begin with. So my final answer here, if I wanted to write it, is all x values such that x is less than -1 or x is greater than 6, because this is an or. Because remember, either or, left or right. The and is in the middle, me and you. So let's see that difference. Look at the difference here. It's actually going to be the same. If you see, it's the same equation. It wasn't done on accident. This one was actually done on purpose. I'm going to erase this. So again, we have to focus on just the x-axis here. I can actually copy this work and paste it because it's the same values. Now something's going to change here. So here's what I want you to recognize. So I'm going to get rid of the blue here. Okay, so now for this problem, look at the difference. The symbol has changed. The symbol is this way. So if I try 0 squared minus 5 times 0 minus 6 is less than 0, if I look here, -6 is less than 0. That's a true statement. So since it works, then 0 is a solution, which means this is an and because 0 is between -1 and 6. So that means all the answers here are the correct answers for this quadratic inequality. So how do I write that? There's two different ways that I can write it. I could say all the x values such that x is greater than -1 and x is less than 6. Or you can put them together if you remember. All the values of x such that x is between 6 and -1. So this is the difference between an and an or. So I'm going to highlight. This is the or and this is an and. So it could be written either way. So here's your answers here. And here, either one is your answers here. These are your answers. So your solutions are between these integers, and your solutions here are in the ors for this one. So there's more than one solution when we're dealing with inequalities. So after you practice graphing, there's one page of 8 questions to practice solving inequalities. So pause the video here, give it your best try, and come back and check all your answers when you're done. So there you have it. There are all the answers and the graphs for all the quadratic inequalities. So I'm going to slowly scroll through them. Pause wherever you need to so you could see the difference of the shading, the dash versus the solid, the turning point, if it's open upward or downward. Very important to pay attention to all those details. Notice how I label every time. And then this is the solving the quadratic inequalities. So you'll see the difference between and or. You'll see the difference between an open circle and a closed circle. For when it's or equal to means it's a closed circle. I hope you remember that from earlier units. And there you have it. That is how you graph and solve quadratic inequalities. So that was your last lesson for the year. And I really appreciate everybody who has been coming in and doing their work and really watching the videos and doing the Castle Learning assignments. I definitely appreciate all the time that you've put. This is, well-deserved, a job well done. I also really wish that we were still in school because it doesn't feel like the end of the school year unless we're there to say bye to each other. But I hope that next year you'll still come and visit me when we do return to school. I should be in the same room, but make sure you come by and say hello because I do miss you. And I really wish the end of the school year could have gone differently so that we can, wish each other the best of luck. Either way, I hope you guys have a great summer. Be safe and be healthy and happy. And hopefully I'll see you guys in the fall. Bye, everybody.